And welcome to the Daily Space Weather Show. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you once again from the Smash News Network, least busted name in news. And tonight we're bringing you some imagery we don't normally show. This is ionized carbon and ionized iron from the Solar Dynamics Observatory. And pictures are worth 1,000 words, so I'll let these speak for themselves. And here comes a series of pretty sweet sets of images in some other wavelengths. Now we're looking at ionized helium and iron. So that's the northwestern limb. That is where I forecasted the largest flares to come from. That sunspot right there. However, I was incorrect. The largest flares came from sunspots not yet visible, from behind the eastern limb. Not up here in the northeast, though. The largest flare was an M-class event that occurred down here in the southeast. So there you'll see it in that video right there. And there is an extreme close-up for you. Let's take a brief moment to take a look at sunspots. So there's a sunspot scenario, and not as many sunspots as I actually expected here. So I'm not sure if they're counting some as set, or maybe some aren't counted yet on the east. Not sure, but we're at about 170 sunspots, I think, if I remember correctly. That is today, January 10th. SDO Continuum. Here's SDO magnetogram, colorized style. And by the way, we've got a cosmic ray report coming to you today. We do that at least once a week on the channel, since they're an important feature of space weather. So next, before we get to any of that stuff, here comes the volcano rundown, and Luotobi is at it. Another paroxysm going on there, producing a 14,000-foot ash plume at Luotobi. Anyway, here's the rest of the list. You've got Suwanosejima, Ibu, like I said, Luotobi, producing some brown clouds, and the alert level remains at the highest level for Semeru, also exploding. 14,000-foot ash plume at Semeru. Merapi, 17,000-foot ash plume. Dacono, Popocatépetl, 19,000-foot ash plume for central Mexico. Santiaguido, Fuego, Nevado de Ruiz, Revenador, and Sabancaya. 23,000-foot ash plume over Peru from Sabancaya. And let's move on to earthquakes. Next, earthquakes. Yes, here are the past 90 days of earthquake activity. And it's been very quiet in the past 24 hours. In fact, I don't even think there was a single 5 or greater magnitude quake. So several happening in Alaska, though, including 3 out there in the Aleutians and several on the mainland. 0 5 or greater magnitude quakes over the past 24 hours. And let's get back to space, where there is certainly plenty of action. Here are the past 24 hours in the wavelengths we just showed before. That's 304 angstroms ionized helium and 171 angstroms ionized iron, 60-minute running difference. So multiple CME events happening in the past 24 hours as well. That stands for coronal mass ejection, when the sun blasts off huge amounts of material, namely, well, mostly hydrogen nuclei, mostly ionized hydrogen. Also some helium, electrons, and some other denser elements are typically contained in coronal mass ejections. And let's talk stats. So the 10.7 centimeter radial flux now all the way up to 186 solar flux units, folks. There it is in the 1-year graph. The black line represents the radial flux. The red line is the sunspot number. Space weather enthusiast dashboard not forecasting any geomagnetic storms. It's calm conditions coming for the next 3 days, and I tend to agree. Next Earth magnetic moment from space. It's our Geospace Magnetosphere movie. That's the past 4 hours of Earth's magnetic moment from space, and again, it's geomagnetically calm. No major space weather events to report. And none in the forecast at the moment. So the sun's not being quite as much of a plasma miser as it was being, but we'll get to that in a minute. These are the past 4 hours of Earth's magnetic moment from the ground level. So a little bit more action than we had in the past couple of days here. There will be some pretty good aurora in some locations. You can see those areas likely to see aurora lighting up there on the map. So some aurora should be visible tonight in some choice locations. KP is currently 2.33. KP 2.33 is the current situation for global geomagnetism. Quite calm. Next, the ACE and Discover. And another prime example of how the ACE and Discover can show very different solar winds at... They're both orbiting Lagrangian point 1. Of course, they can be quite far apart from each other. But in any case, the ACE detecting a much slower and much more diffuse solar wind than the Discover. So there's the ACE at about 2 protons per cubic centimeter and 400 kilometers a second. The Discover is at like 7.5 about 8 protons per cubic centimeter and about 477 kilometers per second. So a much faster and denser solar wind there at the Discover. They both orbit Lagrangian point 1 about 1 million miles in between Earth and Sun. GOES magnetometers are smooth, as we have an extended period of geomagnetic calm conditions. Now, as far as magnetic sectors go, it's actually kind of volatile right now, and here's what we're talking about. So, Earth's just about to snap back into a North Pole sector, so going from north to south and back to north rapidly. So, there you can see that happening in the Gong 2 data, part of the National Solar Observatory. Earth about to exit a tiny South Pole sector into a North Pole sector. So that's likely to happen by tomorrow's daily space weather video. Some volatility magnetically speaking right in between the Earth and Sun at the moment. So the heliosphere is trying to decide magnetism. And right now Earth is still in a South Pole magnetic sector. So you can see that little tiny magnetic sector there in South Pole magnetism. Next, our line of sight field plot. And any of this could change rather rapidly at the moment, folks, because it's a volatile situation down there in the southeastern limb, like we were talking about a couple of days ago before we forecasted those sunspots that appeared yesterday. So anyway, there's our line of sight field plot depicting the photosphere in grayscale, solar B field in blue, north and south solar polar fields in green for north and red for south. Here's our line of sight coronal hole plot. And once again, the B field shown in blue, coronal hole magnetic fields shown in green and red for north and south respectively. So just a little South Pole sector showing up. And here are coronal holes from SDO. Now keep in mind, folks, this is the past 4 days. And this is the past 24 hours. That motion that you see there, that's a calibration move by the SDO to ensure that it is centered on the solar disk. And we do see some nice filament eruptions happening. Let's get the sunspots here. Sunspots, currently at about 172. I'll say 172 is a sunspot number. And here we've brought up the synoptic map because we're having a little bit of trouble loading the Integrated Space Weather Analysis Center. So the synoptic map there are the sunspots. And that's what 172 sunspots look like. If you want to look up the synoptic map yourself, it's from the Space Weather Prediction Center. It's part of NOAA's web suite. And the forecast here, according to the synoptic map, is about a 5% chance for an X-class flare, 45% chance for an M-class flare. So this one was done by Patterson and Brasher at 1400 Universal Time. So it's actually kind of old now. It's about 8 hours old by the time we made this video. But that's the synoptic map. If you want to ever check that out, it's from the Space Weather Prediction Center or SWPC. So Integrated Space Weather Analysis Center is down for the count, I think. Proton flux is at baseline levels. So having seen a significant proton event there, but not major, not only the low-level protons really showed up. And let's get to some protons coming from perhaps outside the solar system. Our cosmic ray update. Again, we do it typically at least once a week. We'll start out with Oulu, Finland. So there's the Oulu neutron monitor. One of the oldest, going all the way back into the 1960s. So there's Oulu, and Oulu's showing a downtick over the past 30 days. No surprise there as we get closer and closer to solar maximum. DOMB Antarctica also showing a downtick for the past 30 days. DOMB Antarctica, a downtick for the past 30 days. Mexico City, a downtick for the past 30 days. Athens, Greece is next, showing a downtick for the past 30 days at Athens. And next we'll go way back up north to Apatity and Barentsburg. So Apatity also down over the past 30 days. And the same scenario with Barentsburg. So cosmic ray flux down for the past 30, and you can expect it to continue to decline for another about a year to a year and a half, as it seems to slightly lag solar activity. So, by the way, if you enjoy the content, don't forget to press the like button. If you're new to the channel, press the subscribe button. Otherwise, how will you get the universe's most comprehensive daily space weather content delivered straight to your YouTube subscription feed? Well, you won't. Although, if you subscribe to smashomash.com/smashteam, that'll allow you to get email alerts from us. Yes, email alerts. We don't rely on notification systems that are created by Google. We don't do things like that. We create solutions, and it's up to you to utilize them. We also create the world's most detailed solar imagery, so cheers. Congratulations on realizing the channel exists. We remain surprised that you have, and let's get on to some more stuff like solar flares. So there's the GOES X-ray flux for the past 3 days, and again, at least one M-class event, just one it looks like. It was an M1.5, a modest flare. And let's take a look at sunspots before we move on to that. Here's a sunspot situation. So yeah, that's what about 170 sunspots looks like. And again, keep in mind there is likely at least one more sunspot very likely to rise over the southeastern limb where we saw that M-class flare. So right down here in the lower left, there is most certainly a sunspot behind there. We don't typically see M-class flares coming from non-sunspot regions. So there are the past 24 hours. That's 94 angstroms SDO along with the 131 angstrom 60-minute running difference. Here we've switched them. Now we've added the 94 angstroms 60-minute running difference and the raw data from 131 angstroms. And were you looking for an extreme close-up of that M-class solar flare? I'll bet you were if you're watching our channel. So, okay. Ask and ye shall receive. If there's something else you're looking for, ask for it in the comments. Or better yet, check us out on other social media. We do read all comments, though, folks. Anyway, those are the past 24 hours at the southeastern limb, and new sunspot likely to rise down there, and it's likely to be a magnetically complex one, having already produced an M-class flare before even coming into view. Facts. Perhaps too many of them on the channel for people to be in their comfort zone. Oh my God, have you left your comfort zone? Dear God, calm down, folks. Civilization's still not ending. So, next a star chart. And if you're looking for Polaris, did you know that it's all the way at the end of the tip of the handle of the Little Dipper? There you go, Ursa Minor. The Little Dipper, Polaris, at the handle. And if you want to see how to find it, one of the ways you can find it is by using the Big Dipper. You know, the Big Dipper actually points at it. So the end of the Big Dipper right here, this portion points right at Polaris. The part where the milk would spill out of the Big Dipper, that part points right to the North Star, the convenient North Celestial Pole. Anyway, here's a solar system forecast. And by the way, thanks for tuning in to the Smash News Network, least busted name in news. This is where things are today. That's where things will be in 1 week. Next, our astronomy photo of the day, which is S2155, the Cave Nebula, which features a bunch of blue giant stars, like type O stars, which are blue, hot, rowdy stars, as well as that red star there, which is a Herbig-Haro object. The type of star believed to be involved in the production of new planets, like a planetary nebular type star, surrounded with a bunch of gas and hence some spectacular color there as a bunch of ultraviolet light illuminates a bunch of dust and gas and so on. It's a busy area, and that's the SH2155 in the constellation Cepheus. Here's another quick look. If you want to check it out yourself, it's apod.nasa.gov. Not half bad. The Cave Nebula, folks. Which brings us to coronal mass ejections. It's time to see what's been blasting off. And there's what here are CMEs from today. And we're interested in figuring out if there are any earthly directed ones. So, shall we? That's only 46 frames from today, interestingly enough. Let's take a look at C3 as well. They don't look earthly directed to me. What do you think? Here are our custom coronagraphs. And yeah, if there's something headed Earth's way, I'm not seeing it. Let's zoom in one step here. And what do we got? Anything with an earthly directed component? Fingers crossed, folks. I don't think so. One of the ones from this active region up here may have an earthly directed component. If so, it's likely to arrive on about the 13th. So, but if so, it'll be minor because it's clearly not entirely earthly directed, if it even does have any earthly directed components. We do see some plasma motions kind of right in the center disk also, but I don't think that was a CME. So here's another 24-hour video for you. There you go. That's the 193 angstroms running difference of 60 minutes along with the 304 angstroms SDO. So Solar Dynamics Observatory, thank goodness for that telescope. That is a good one. And let's move on to filaments. Filaments. Wherefore art thou filaments? Because magnetic fields are suspending plasma above the solar surface. So we've got some rather gargantuans here hanging out around the northeast, which is up here. Right there. We got two large filaments up there. Those could use names. There you'll see those dark absorption features there rising up over that northeastern limb. So those could be named. If you want to name sunspots, if you want to name filaments rather, name them after living people, your friends, your foes, or even yourself over at x.com/smashomash. Just follow the hashtag #NameThatFilament, and we'll do just that. CME kicking off as we create the video, and also some minor flaring activity there in the west, right where we forecasted it to be yesterday. Looks like it was a little bit late, but there still is a significant chance of large solar flares in the northwest. So we'll have another 18 to 36 hours before that's out of the flare likelihood zone. So that's what's going on. Let's get the bonus features. Bonus features. Starting out with satellite charging hazards. Last I checked, and we have some. So there you go. Some charging hazards there. Minor surface charging hazards over the Middle East. That's what's up. Won't cause any major communications errors. The GOES electron flux here is, well, the GOES 16 is really low and the GOES 18 is low. There's the past 1 year of relativistic electrons. They're measured by the GOES 16 and the GOES 18 using radiography. There's the forecast from NOAA, expecting flat levels, and no reason to argue there. It's a bit of an electron shortage going on. Next, we'll show the layer where it's measured, the F layer, which is located at about 300 kilometers of altitude. Here it is from Australian Government Bureau of Meteorology in megahertz, millions of vibrations per second. It's diffuse gas, which means it's able to vibrate very rapidly. And it's mostly ionized material, so it is affected by the sunlight. The ionosphere puffs up, especially at noontime around the equator, which is essentially what you're seeing on this imagery. It becomes both lower in altitude and higher because it puffs up in all directions. Here is the anomalygram. That's anomaly in megahertz from a 30-day median. And once again, if you're looking for a doomsday forecast in the ionosphere, we're terribly sorry, but there is no doomsday forecast available in this data. Next, the WHAM. And I'll just say, wake me up before the total electron content is on the left with the maximum usable radio frequency on the right. Wake me up before the WHAM model, the whole atmosphere model. Get it? The WHAM, the whole atmosphere model. Oh, anyway. That's what's going on in terms of total electron content and maximum usable radio frequency. We'll close out space weather with the latest high-res images. So there you go. I'm not going to zoom in on any of that stuff because, oh, wait a minute. Never mind. New sunspot just rose in the northeast. So that's a thing. And the next thing is the meteorology segment. So we're going to talk about ice and snow and sea surface temperatures and sea surface temperature anomalies and all kinds of things. These are sea surface temperatures and ocean winds. Well, sea surface temperatures and surface winds. And we're going to switch to sea surface temperature anomaly. I'm just showing you the extent of the Arctic ice. I guess I better show the Antarctic ice as well. Wow, very low Antarctic ice. Of course, it is summertime down there. Now, sea surface temperature anomaly is what we want to show. So there are the sea surface temperature anomalies for the Atlantic, along with the surface winds. Sea surface temperature anomalies for the Southern Ocean, the Indian Ocean, and the Pacific. It's so big it barely fits on the map, but there it is. 1/3 of the Earth's surface there, covered by one body of water. It's gargantuan. And let's get on to our regularly scheduled meteorology segment. So here we are, surface winds of the east, jet streams of the east, jet streams of the central world, surface winds of Europe, Africa, and the Middle East, surface winds of the Americas, and jet streams of the West. Next, we're going to look at snow and ice. So first, snow, and the extent has finally moved back into the average. So the extent was very low. That's the two-dimensional amount of basic ground that the snow covers is the snow extent. and now it's right in the average. That is the plus or minus 1 standard deviation for 1998 through 2011. Very average. Snow water equivalent here, over 1 standard deviation above normal, meaning there's some deep snow in some places, undoubtedly. And the snow mass volume here right in the middle also, right at the median of the 1982 to 2012 plus or minus 1 standard deviation range. So that's what's going on with snow. As far as what's going on with Arctic ice, it's really low as far as Arctic ice volume. So it's very thin, and that's the volume. That's the extent times the thickness, effectively, and it's almost as low as it was in 2021. So Arctic ice is quite thin. Next, moving to the ever-popular clouds and fog. Yeah, we like to show clouds and fog, even at nighttime. That's why we use the shortwave radiation map. Gotta love the shortwave radiation map, folks. So that's 3.9 micrometer infrared. Here you can see those systems that were affecting the eastern U.S. last night moving on their way out into the Atlantic Ocean, making their way off to, that's Pacific moisture there, folks, making its way all the way over to Europe. Anyway, we decided to center the map today on the border between Indiana and Illinois because we've got another low, like we said yesterday, would form here moving across Nebraska. So it's moving east-southeast. It's just about to make its way into Iowa and Missouri. You can see that counterclockwise rotation there showing you the center of that new low, which will produce new effects for large portions of the country. So that's next on the list. And here's our precipitation type. I like to show the precipitation type map because I want to know if it's snowing or raining, and it looks better than it did. But still lots of slushy, wintry mix type stuff falling on Pennsylvania. Rain with snow. Ew. Insta slush. Who wants insta slush? No thanks. Here's your weather.gov map, and we've got a bunch of weather warnings there. I think that might be too many for us to cover. So if your location is lit, just head to weather.gov and get your lit forecast. We hope your forecast is lit or something. Weather.gov. And here comes some forecasts. First, the GFS 72-hour pressure and precipitation. By the way, if you want a shirt just like mine, head to amazon.com/shop/smashomash. Head to the Spacewear collection, and you can get one exactly like this. This is the kahuna or something. But yeah, there's that low, and you can see it's going to make its way up to the Great Lakes and then into Canada and then skirt across the U.S.-Canada border as more heavy snows show up in the Pacific Northwest and California. Anyway, that's the map. You can see the map at 72-hour GFS forecast. Here's a 72-hour GFS accumulated positive snow depth change in inches. And, that's quite a bit more snow coming, folks. Quite a bit more snow coming. But not for us. Lehigh Valley, PA. Looks like no snow coming for us. So there's that. Here's our temperature anomaly forecast in degrees Celsius, as this cold Canadian air is just kind of stagnating here now, just hanging out in the middle of the country for multiple days in a row and reaching all the way down into the Gulf of Mexico. Cold Canadian air there. Parts of Montana will be at like 28 degrees Celsius below normal. And imagine what normal is for mid-January. Dag. Also northern Idaho and parts of Washington expecting some shockingly cold temperatures. In fact, the Great Plains in general will be frozen solid. It's a deep freeze coming, as extremely warm temperatures strike the east side of the country. Quite the opposite there, with 20 plus degrees C above normal in some areas. Anyway, here's what's in charge of that. Once again, it's the jet stream is the culprit. Huge kinks in the jet stream allowing cold Canadian air to be pulled way down south and warm southern air to be pulled way up north. The jet stream, it's what's really in charge of your weather. Unlike things like cloud seeding and HARP and contrails and all of this other nonsense that isn't weather modification in the first place, the jet stream, it actually does control your weather. The upper level wind patterns, the 250 millibar winds, are what the forecast is for GFS 72 hour. So there's that. Next, lightning. And here's a real-time lightning map from lightningmaps.org. What do you got? Do we have any strikes? It's pretty calm. Only 17 strikes per minute. Make it 70 strikes per minute. That's still a low number of strikes. We do have some power outages in the U.S. continuing. New York has the most with 82,000. So quite a few folks without electricity right now. It is quite windy in Pennsylvania. We'll close out with Doppler radar, clouds and fog, and water vapor. So there's Doppler radar for the full 50 states. We'll focus on the lower 48. Clouds and fog is next, as that low rolls across Nebraska mainly into Missouri. And here is the water vapor map as moisture moves across Wyoming, crossing the Rockies. Here's our recap. Vertical motion in the air column from ground-based Doppler radar systems. They show precipitation when calibrated correctly. Space-based systems at 3.9 micrometer infrared radiation, showing clouds and fog even at night. And another satellite showing water vapor, and that is where we will close this thing out. Thanks for tuning in, folks. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back while I go back to the bunker again. I'm gonna eat MREs until my gut begins.